Assalamu alaikum, my friends. Today we have to discuss about the titration. Titration is basically classified into general groups. These two are the acid-base titration and the redox titration. But in this lecture, we have to discuss about the acid-base titration. So, in order to understand the acid-base titration, first we need to know some of the basic information about the acid. So acid is technically, in term of the strength, it is classified in two different groups. One is the strong acid, other is the weak acid. Uh, the general examples of the strong acids are HCl, that is the hydrochloric acid. Next is the H2SO4, that is the sulfuric acid, and the HNO3, that is what is the nitric acid. And the next category is the weak acid. The two basic examples of the weak acids are this one is the acetic acid, and next one is the oxalic acid. Well, in the same way, the base is also categorized, okay, in terms of the strength. So that is the strong base and the weak base. The strong base, the general examples of the strong base are the sodium hydroxide, means to say the NaOH, and the second one is the KOH, named as potassium hydroxide. Well, the second classification of the base, that is a weak base, and the general examples of the weak base are this Na2CO3, means to say that is the sodium carbonate, and the other one is the K2CO3, that is the potassium carbonate. But knowing all these acids and the base with their strengths, we can further understand about the basic facts of the acid-base titration. Well, the glass sphere, this is very much necessary. First, we have to understand about the glass sphere before we start understanding the titration. So these are the basic glass spheres. One is the beaker, as we know, this is the beaker. Other is this one is the pipette we generally use for the titration purpose. This is the dropper, what we have to use for the indicator, and this one is the bottle for the indicator we use, different kind of indicator, and we'll be discussing that in detail uh, in this lecture. Well, this one is the conical flask. You have to all these friend. You have to remember the name of all these glasswares. Well, this one is the longitudinal tube. This is what is the burette, and the next one is the burette stand, by which the burette is hanging in the longitudinal form. Well, next, the titration types we have to understand. The titration may be categorized on the basis of the strength of the acid and the base, or the strong acid and the strong base. The first category, we only have to use one acid and one base for the titration purpose. So if the first condition, when the acid is strong and the base is also strong. Second one is when the acid is weak and the base is strong. Third one is the acid is strong and the base is weak. And the fourth category is the acid weak and the base is also weak. Well, among all these, the last condition, that is what is the weak acid and weak base, we do not have to discuss this. Okay. For the beginners, this category is not uh, discussed, because this is very much typical to handle this situation when the acid and base both are weak. So the endpoint and the experimental procedure would be very much difficult for controlling. So we only have to discuss the three types: a strong acid is strong base, weak acid is strong base, and a strong acid weak base. Next is the selection of indicator. This is pretty much easier. Uh, First, when the base is strong, the condition why the base is strong, we have to use the phenolphthalein every condition. So in the second category, that is a weak acid and a strong base, since in this category, the base is strong, therefore the indicator should also be the phenolphthalein. Well, in this condition, whatever the strength level of the acid is, we just have to focus here. The base is weak. Since the base is weak, so we have to use the phenolphthalein. So students, we only have to remember the base when it is strong, we have to use the phenolphthalein indicator, and when the base is weak, we have to use the methyl orange as indicator. Next, the selection is the reagent. Which of the reagent should be poured in the burette? So this is very much easier once again to understand or to remember. Once again, the same thing. The base is strong. When the base is strong, so it should be in burette. Again, the strong base in burette. No, over here, this is the weak base. So this is the other condition. Now the acid should be in burette. Okay. You have to follow this instruction because in every category, whether it is the category 1 or 2 or 3, you just have to decide which of the reagent should be poured in the burette. So on the basis of the strength of the base, you have to select this. Moving to the next point, this is the first classification of the acid-base titration, that is the strong acid and strong base titration. So this is the object 1. This is what is the determination of nobility and amount of NaOH. NaOH, this is the base, and as if you remember, this is what is the strong base in gram per 850 centimeter cube. Centimeter cube is basically the unit of the volume. You should know about this is what is the unit of the volume. Given 0.1 and solution of HCl. Now this is the HCl. This is a acid, and this one is the strong acid. So just by reading the objective, you first have to mark it with the strength of the acid or base. So this is the first category, strong acid and strong base titration. So you have to recall in your mind, as I have shown this in the previous slide, that the first thing, the indicator what you have to use is the phenolphthalein, because the base is strong. Next, in burette, what should be placed? That is once again the NaOH, because the base is strong. So let's start working. First, you have to fill this burette with. You should remember this is what is the NaOH. So along with the NaOH, we have to fill this burette, and you have to fill this burette up to the 0.0 level. Well, you'll be watching when you have filled the burette, so there would be a lining like this. This is the curved line. So this is what is called the meniscus. So this is point is the lower meniscus, and this is what is the upper meniscus. So how you have to watch this? This is the correct way of watching the meniscus level. That will be the correct one. If you're watching it from here, that's wrong. If you're watching it from here, that's wrong. So at the eye level, you have to watch, and you have to focus on the meniscus level, the lower meniscus level. That will be showing you the correct reading. So finally, you have filled this burette up to the 0 mark. So that means the burette is having generally it is the 50 ml burette. So this burette is having the 50 ml of volume of NaOH. Well, Next, what you have to do, this is a beaker, and beaker must be having is what is acid. Let's consider this is beaker is having acid, and which of the acid, as you know, you are given the HCl, so it must be having the HCl. So you have to take the 10 ml volume by the this pipette. So what is the 10 ml? You have to take the 10 ml volume by the pipette from this beaker having the HCl. And there is a conical flask that this 10 ml volume you have to transfer into this conical flask. So currently this conical flask is having the 10 ml HCl, and then you have to add a few drops, one or a couple of drops of the indicator. And which of the indicator you have to use? You have to remember this is what is the phenolphthalein. So this conical flask is having 10 ml HCl along with the few drops of phenolphthalein, and we have to take all these underneath the burette. And the burette, what is it having? This is what is it having NaOH, and this conical flask is having the HCl. What happens? The drop by drop you have to insert, and there will be some decrement in the volume of NaOH that will be consuming in order to react with the HCl. So at last, what happens? There would be the color change in the conical flask. So if the drop you if you drop you insert in the conical flask that is having the HCl, so this will be showing this color. This is, let's say this one is the A, and this one is the B, that is having a somewhat darker in color, and this is the more darker one, and this one is the most darker one. So which of the best reading? The best reading would be the A, that is having the very light color of the pink, light pink color. So you must have to know about that. There should be the lightest of the pink color should be, so that will be the more accurate or the correct reading. As much it is darker in color, that means you are inserting more error in your analysis. Well, after having this color, you have to note the reading, that the how much quantity of NaOH you have used, and the volume of NaOH you have to insert, and I'm showing that in the next slide. After the analysis, we have to write the result whatever we have taken the readings. So here's the summary, that the first reading you started from zero point 0.0 reading, that initially when you started the experiment, so the volume of the burette was showing the zero point 0.0 centimeter cube volume. Uh, Let me tell you, the centimeter cube or the ml are the same thing. So whether we say the centimeter cube or the ml, they're the same thing. Well, after taking the reading, the final volume was 8.2 centimeter cube. So finally, the 8.2 minus any final minus initial is 8.2. That is the difference of the reading. So 8.2 centimeter cube was of NaOH was consumed for the neutralization of HCl. So for the surety, we have to repeat the reading. So this is the second set. Again, you have to you have to again you have to take the empty conical flask, and once again you will be inserting 10 ml HCl using pipette, and then along with the one or two drops of phenolphthalein. Then again you have to start taking the reading, and the initial point for set 2 will be the final reading of the set 1. So this is why I'm copying it from here. So the initially now is 8.2 ml of the centimeter cube. No, in the set 2, once again we started taking the readings. So when the light pink color appears, the final volume for this set of the burette was 16.5 centimeter cube. So what was the difference? The difference is 16.5 minus 8.2 is 8.3. So over here, there's a slight difference between the 8.2 and 8.3. There's a slight difference. So for the surety of the result, we have to take the other reading. So this is what it is set 3. So for this set 3, the initial point was the final reading of the set 2. So that's why I'm taking the initial reading, that is 16.5 centimeter cube. Well, after taking the complete reading, when the light pink color appears for the set 3, so the burette reading was showing 24.8 centimeter cube. So what was the difference? That is a 24.8 minus 16.5 is equals to 8.3. Now over here, this is the 8.3 and the 8.3. These two are the same reading. The consecutive same reading means to say this is the correct one. So we have to take this concordant volume of NaOH is the correct one, that is the 8.3. So this reading 8.2 we have to ignore because we only have to take the concordant or the same reading. So well, the volume of NaOH consumed during this experiment is 8.3. So this is a summary of the object has been given. Let's take this one. The volume of base, that is what is the VB, and as we know, the volume of base means to say the volume of NaOH. So from the burette reading, every time you have to write the burette reading here. This is what, in this case, the reading shows, the observation column shows that is what is the 8.3 ml. So you have to write here the 8.3 ml. Now the solution in burette, the solution in burette, as we have discussed, that is what is having the strong base, that is the NaOH. Normality of acid Na, that is 0.1 N, where it comes from. So it is given in the object. This is what is the given 0.1 N solution of HCl. So this is what I'm copying it from the object. Next, the volume of an acid Va, that is a 10 centimeter cube. So where it comes from, this comes from that the volume of the pipette, whatever the volume of HCl we have taken from the pipette and into the conical flask, that was the 10 centimeter cube. The indicator used, you must be remembering that the indicator what we use is phenolphthalein. Next, the solution in conical flask. So fourth, since the solution in burette was the NaOH, so solution in conical flask is HCl. Next, the normality of base. Normality of base is unknown because what you have been asked for the question is the determination of normality and amount of NaOH. But amount of NaOH and the normality of NaOH has been asked to determine. So this is still unknown. So for the further calculation, we have to calculate the normality of base, that is NB. Well, the color change, what happened? It was colorless initially. When you inserted few drops of phenolphthalein, the solution in the conical flask was colorless. And then the reading appears, that was the pink. So this is what the experiment is, from colorless to pink. So there's the whole scenario on the whole observation, the summary of the observation. Next, what I have to do, that is what is the calculation. So moving to the calculation, first you have to calculate the normality. So for the formula of calculating the normality is Na, A for the acid, Va, that is the volume of acid, Nb and Vb respectively. These are the normality and volume of the base. So this is the formula. We may write like this, and putting the value of Na, that is normality of acid, this is 0.1. Once again, I'm marking it here. You have to copy it from here only. This is the 10. This is the volume of acid, whatever we have taken from pipette. And this is the 8.3. This is the volume consumed from the burette, and that was a file reading of ours. This comes from the burette. So finally, after calculating, the value is 0.12 n, that is the unit of the normality n. So this is what is the normality of NaOH. Whatever has been asked, we have calculated the determination of the normality and the amount of NaOH. So the normality we have calculated. That is what it is, 0.12 n. Next, the B part, that is the calculating the equivalent weight of NaOH. In order to find out the amount of the second phase and the amount of NaOH, so in order to calculate the amount of NaOH, we have to find out the equivalent weight of NaOH first. So the equivalent weight of NaOH, what is the formula? This is the molar mass of NaOH divided by the acidity of NaOH. So acidity of NaOH, what does this mean? So I will explain this later in the other lecture. So, but in this case, you have to remember when there is a acid is HCl and the base is NaOH, so the acidity of NaOH would be 1. Okay. In most of the cases, there would be the one acidity of base or the basicity of the acid, that would be 1. But I'll explain this in detail in upcoming lectures. So over here you have to calculate the molar mass of NaOH. The NaOH, sodium is 23, oxygen 16, hydrogen 1, and we have to calculate the molar mass, that is the 40 divided by 1 is 40. So the equivalent weight of NaOH is 40. So we have to use this value, the equivalent weight. So moving to the next one, and the part C we have to calculate, that is the amount. Well, this is the amount of NaOH in gram per 850 centimeter cube. So what is the formula to calculate the amount? This is the amount of NaOH in gram per 850 centimeter cube. So what you have to write, the normality of NaOH, as we know, this is the NB, and that is what we have calculated in the part A. Equivalent weight we have calculated in the part B. Given volume, and this is the volume, that is a given volume, 850 centimeter cube. So normality we have calculated, that is the NB, that is 0.12. Equivalent weight, previously in the previous slide we have calculated, that is 40. Volume, that is given in the question, that is 850 centimeter cube. According to the formula, that is 1000 and divided by 1000. Overall, the calculations show that is 4.08 gram. The answer should be in gram. A gram per 850 centimeter cube. Overall result, this is the normality of given NaOH solution is 0.1 n, 0.12 n that we have calculated in the part A, and the amount of NaOH for the given solution is equal to 4.08 gram per 850 centimeter cube, and that is what we have calculated in part C. Well, thank you very much. Thanks for watching.